My name is Helen Oku, and I'm here to talk with you about nuclear energy. Behind the Argonne Nuclear Facility, and they have a lot of different things about nuclear energy and how it works. Throughout the video, I will show you some pictures and some segments from this place, and hope you enjoy the show.
First, let's start off with the basics. Right now you may be asking, what is nuclear energy? Nuclear energy is the energy that is harnessed using nuclear reactions. Now I'll tell you how it's harnessed. It all starts with nuclear fission. This process sends a neutron into a rod with uranium atoms. Once a uranium atom is hit with neutrons, then the atom splits into two parts, one with neutrons that came from the uranium atom, and another part with energy in the form of heat. The new neutrons go forward into splitting more uranium atoms and generating even more heat. While this is happening, there's water coming around the rods from the condenser, and this water is boiled because of the extreme heat coming from the uranium being split apart over and over again. The steam from the water goes up into the turbine blades that are spun. Attached to the turbine blades, there's coils of wires that, when spun, are generating a magnetic field, and this is how energy is made. After this happens, the energy is sent through transmission lines, which are either underground or outside. They bring energy into people's homes. This is all monitored by the Department of Energy. Whoa, wait a minute. It's all right if you didn't completely understand everything I just said. Here's a diagram that might help. The water flows from the condenser, which is the pipe at the bottom, then gets heated from the nuclear fission occurring over and over again in the reactor vessel. The steam that was the water goes up to spin the turbines and power the generator, which gives off electricity. Hopefully this diagram cleared up a few things. Now let's go back 78 years. It all started with two German scientists in 1938, right before World War II. Their names were Otto Hahn and Fritz Strassmann. They noticed that when uranium atoms were hit with neutrons, the uranium atom would split into two pieces and it would produce a lot of energy. What they discovered was nuclear fission. Their discovery led to Nazi Germany attempting to build what would become the atomic bomb. Albert Einstein knew of what Germany was trying to do and warned the US. Then America was in the race to invent the atomic bomb. On July 16, 1945, the U.S. tested the first atomic bomb on a remote airbase in New Mexico, and the bomb was a success. And the next month, the U.S. dropped the atomic bomb on Hiroshima. After that, almost every first world country wanted the technology of the atomic bomb, and 9 years after the bomb was dropped, the world's first commercial power plant opened in Obnas, Soviet Union. Finally, the world decided that using nuclear fission for an energy source would be better than only using it for weapons. And in 1957, 3 years after the first world nuclear power plant was built, the International Atomic Energy Agency, or the IAEA, was created to encourage peaceful uses of the atom. Though many countries still use nuclear energy, it is well known for the destruction it caused in Japan, and many countries still possess nuclear weapons. Now let's get a look at where and how uranium can be mined.
Three types of uranium mining. Open pit mining involves clearing the land, soil, and rock to extract the uranium ore. On average, the ratio of this waste rock to ore is 30 pounds to every pound of ore. This tremendous amount of waste, which contains radium and other metals, is disposed on site. Underground mining produces less waste rock but poses a greater risk to the health of miners due to the confined spaces. Lastly, there's in situ mining, in which chemicals are injected deep into the earth to dissolve the uranium and bring it to the surface. This is the only type of mining that is regulated by the federal government.
There are many places where uranium can be mined on Earth. This chart shows the amount of uranium per country. As you can see, Australia has the most uranium on Earth, followed by Canada, then Kazakhstan. Here you can see in the world which countries mine uranium and compare the amounts between each country. The darker the purple, the more uranium is mined. In this map of Australia, the green dot represents operational uranium mines. The orange dots represent major deposits of uranium, and the red dots are former uranium mines. This is a map of Canada's uranium mines. The red dots indicate where the mine is operating, the bright green dots show where the mines have been proposed, and the dark green dots are former mines. This map shows the uranium concentrations in the U.S. Red is the highest concentration, then it goes down to orange, then yellow, then green, and the lowest concentration is blue. This map shows the amount of operating nuclear reactors in the world. The bigger the dot, the more nuclear reactors are in that country.
Many people believe that nuclear energy is not a good source of power because of the reputation nuclear fission has with destruction. But nuclear is the most efficient energy source that we can use. While producing it, no greenhouse gases are emitted and it doesn't contribute to global warming. Nuclear fission gives off an enormous amount of energy, a lot more than you can get with the same amount of coal. If this hasn't already convinced you that nuclear energy is great, then I'll have you know that this energy produces 24 hours a day. That's right, not only when the sun's out or the wind's blowing, you heard me right. And you only need a small amount of uranium to produce a lot of energy. So go nuclear! But wait, before you go headfirst into nuclear energy, you should probably know some things about it. After nuclear energy is produced, nuclear waste is a byproduct of the energy and it's radioactive. It is very dangerous and needs to be watched for about 10,000 years before it's safe to leave alone. And at power plants, accidents can happen and people can get hurt and die. Also, if a terrorist would attack a power plant, then the attack would have catastrophic consequences, and the nuclear waste can be used as weapons. Not to mention that this is not a reusable source of energy, and uranium is a scarce resource and only estimated to last about another 30 to 60 years depending on demand. If you're an environmentalist, then you may have some concerns about how nuclear energy has an impact on the environment. If nuclear waste is properly contained, then there will be no environmental impacts on the surroundings. However, if there's a malfunction with the containment, then radiation will affect the environment in many horrible ways. Animals and plants that populate the area could acquire cancer and have genetic complications for generations. There are many precautions that nuclear waste has to go through, so we know that radiation won't go into the environment, so we rarely have problems with the containment. But don't worry, even though there's not a 100% chance that nuclear waste is safe, scientists are working on better containment of the waste. And you can do things to help reduce the amount of energy we use. You can turn down the temperature in your homes. You can carpool, bike, walk, and use energy efficient equipment that uses less water and or heating. And you can get word around to everyone in your community to do this too. I'm positive that this will help the world get to a better place. If you like the sound of nuclear energy, then I'll tell you a few jobs that you can do to help in the field. There's an entry-level engineer who troubleshoots in power plant operations. They monitor, assess, and improve power plant systems and components. Also, they monitor equipment performances. To do this job, you need a Bachelor of Science degree in engineering or equivalent, and the median salary is $90,960. Another job you can have is being a nuclear chemist. Their job is to monitor, review, and evaluate chemistry controls and conditions to set things up correctly in the time and place. The educational requirements for being a nuclear chemist are a bachelor's degree in chemistry or a related field, and a master's degree or a PhD in nuclear chemistry. And the median salary is $77,740.
One last job is being a
mechanical technician. Their education requirements are a high school diploma, 2 to 4 years of experience with passing of your exams, and sometimes an associate's degree. This job has a median wage of $53,830. In this job, you repair and inspect a variety of valves, pumps, and other related equipment. They also work with others to do this. Earlier in this video, I mentioned nuclear waste being the only source of pollution that this energy emits. Nuclear waste is the used nuclear fuel that was in the reactor. Since the fuel was used, now it is no longer only uranium and it's radioactive. There are 3 different main levels waste can be. There is low-level waste, intermediate-level waste, and high-level waste. The low-level waste is the least radioactive and the easiest to clean up. To clean it up, first you put it in containers and then you store it in a safe place with a man-made underwater pool to help speed up the process of making it safer. You leave it in there for about 15 years and then it is disposed of as regular waste. Intermediate level waste is harder to clean up. First, the waste is stored into steel containers and put into concrete boxes, then again into a concrete trench, which is at least 18 meters deep. A concrete slab is placed on top of the trench and then topped again with a layer of clay, then concrete, then clay again. High-level waste is the most dangerous and harmful waste that there is from nuclear energy. It is 90% of the waste. It takes thousands of years for this waste to be safe for the environment and takes a lot of precautions beforehand. To store this waste, first it is made into a powder,
and a mixture of the waste and glass material mixture is made with a 25% of it being the waste and 75% of it being the glass mixture. We combine it, then put it into a steel container. People who work with nuclear waste have to have protection from the waste itself. Here are some pictures of people in costumes and some of the materials themselves. As you can see, their whole bodies are covered. Starting from the top, they have masks they have to wear to cover their faces, and on top of the mask, there are hoods they have to wear. The hood is part of a full body outfit they have to wear. It's like having a onesie with a hood and gloves. In addition to the gloves that are built in, they have to wear gloves over the suit. On the front of the suit, there is also an additional apron. And on top of the built-in foot coverings, there are another set of materials over your feet. Here are some people working with nuclear waste. This is something else people who work with nuclear waste use. It's called a glove box. The point of it is to have radioactive materials in the box while the worker doesn't come into contact with any of the waste. Also to have the radioactive materials in a confined space. Overall, I believe that nuclear waste is an acceptable give-off for the amount of nuclear energy produced. Nuclear produces so much more energy than other sources, and if the waste is disposed of correctly, there are no significant negative effects from using it. Not to mention the amount of nuclear waste produced is relatively very small. About 210 cubic meters of waste is produced every year. That's about the size of 3 Olympic swimming pools. Compared to the amount of energy that is given off throughout the year around the world, I'd say that's a pretty small amount of waste. Are you ready to talk with someone who works with nuclear energy?
Hi, my name is Vadim Sajayev. I'm a physicist at Argonne National Laboratory in suburbs of Chicago.
Okay, so I have a few questions for you about nuclear energy. So, how does nuclear energy play a part in your daily job?
In my daily job, we don't work with nuclear energy. We don't really work with nuclear energy. We work with we help people study how to make how to produce nuclear energy better. So, in my personal daily job, it's basically like in everybody else's life in Illinois. It's just 50% of electricity that we consume, everybody in Illinois, is produced by nuclear energy.
Where do you harness the uranium that's used?
Uranium is for nuclear energy production is harnessed it is mined from the ground. So it's there are about 60% of all uranium produced in the world is mined in 3 countries: in Kazakhstan, in Canada, and Australia. So U.S. has some mines, uranium mines, but U.S. buys most of its uranium abroad.
What are some advantages and disadvantages of using nuclear energy?
Nuclear energy is the cleanest source of energy available to people. That's as they say, on demand. Because like wind or solar energy, they're clean too, but you cannot produce electricity at night, for example, or when there is no wind. So nuclear energy can be produced always, and it's really clean. So that's the main advantage, is it being clean. And it's when the power plant is already constructed, the electricity is really cheap. So the disadvantages is that to mine the uranium is pretty dirty job. To build a plant is very expensive, and then to dispose of the nuclear waste after the nuclear fuel completed its cycle is also a hard job, a hard and expensive job. So it has its advantages and disadvantages. So, and I think that the people who work on the improvement of this the whole nuclear energy process, they will work on emphasizing the advantages, and they will work on overcoming any disadvantages that there are.
Okay. And so, what are some environmental impacts of using nuclear energy, and how can we help to stop them? Let's get into nuclear waste.
Yeah, I guess I already talked about it. So it's environmental impact. As I said, it's it's really clean. It's even if we talk about radiation, the coal plant actually in its daily work produces about 100 times more radiation than nuclear plant. So the power plant is really clean, and by utilizing nuclear energy, US actually saves, well, it actually makes environment better. So of course there is an impact when you mine uranium. So to improve that, I guess you have to have better regulation and better supervision of the companies that mine uranium. And for the disposal, there is a lot of, the disposal is actually a pretty political question. There are some ways to dispose of used fuel in some deep underground caves, but there is no decision in the U.S. Congress that would allow to do that. So it's one way is to work with your Congress.
Okay. All right. So how is nuclear energy harnessed in like a general?
In general, so the atom of uranium splits into, it spontaneously, well, first it emits neutron spontaneously. Uranium is one of the few elements on Earth that can do that. So then that neutron can be absorbed by another atom of uranium, and that makes the atom split. The atom splits into two pieces that have less mass than the starting atom, and that difference in mass of the first atom and then two atoms after the split, that difference is converted into pure energy. So basically, when it splits, it emits heat. So the reactor is basically heating the water through this process of, it's called fission. So it's heat the water, and then the water turns into steam and rotates turbines and so on. So the end, the production of electricity is same as most of the other plants. They like coal. They also heat water.
Okay.
So that's, and it's actually the energy that's stored in uranium for the same amount of material. It's I think like almost a million times more than the energy stored in the same amount of coal.
Okay. And then why do we use uranium like for fission versus like other materials?
It's, as I said, one of the few materials on Earth that can spontaneously emit neutron, and then after the fission, it splits into two smaller atoms and 3 neutrons. So it basically multiplies the amount of neutrons. Those 3 neutrons that emitted, they can be again absorbed by nearby atoms. Those atoms will split, and amount of neutrons available for this fission, it multiplies. This is called chain reaction. So this is one of the few materials on Earth that can easily support a chain reaction.
Okay. All right. Thank you for the interview.
That's all.
Yeah.
My pleasure.